STP conditions. And STP conditions is just referring to standard temperature and pressure. So what that means is this has been decided that STP conditions are just kind of a standardized set where the temperature is 0 degrees Celsius, or actually in Kelvin that's 273.15 Kelvin. So this is the standard temperature, and the standard pressure is 1 atmosphere. Perfect. So that's all STP is just using an ideal gas under this certain set of conditions. So what we can do here is write out the ideal gas law again. We have PV is equal to N RT. There we go. So now using the ideal gas law under these STP conditions is really good for finding how much volume gas occupies, in these conditions. And actually, there's a really good conversion factor that you guys should be aware of. It is that here. I'll write it in red here. It's that 1 mole. Here, let's make sure this comes out. 1 mole of any gas at STP. This is really cool. 1 mole of any gas in standard temperature and pressure conditions is going to have the volume of 22.41 liters. Now, before we move on, I'll just show you. I'll show you why this happens. Actually, it's kind of cool. So if we just rearrange this, we want to isolate for volume. So we get volume is equal to nRT. nRT all over P, all over pressure. Okay, so now what we've said here is, well, we were talking about 1 mole of any gas. So for N, we'll substitute in 1 mole. And then R is our universal gas constant, and we're going to be using atmospheres for our units. So we use 0.08206, and this is atmospheres per mole per Kelvin. Okay, and now our standard temperature is 273.15 Kelvin. 273, I'm sorry, 0.15 Kelvin. Usually with the problems we've been just kind of rounding off to 273, but in this case let's actually include the 0.15 here, and this is important. So now what we have to do is we just have to divide this by our pressure, and our pressure is just, well, it's just 1 atmosphere, all over 1 atmosphere. Okay, so this is our standard conditions for 1 mole of any gas sample. And if you go through this and you multiply this out, you'll find actually you're going to get 22.41 liters. Okay, cool.
So the mass of carbon dioxide is 125 grams. Now, we have the temperature being constant and the pressure being constant. In this case, we use Avogadro's law. And Avogadro's law states, sorry, let me just erase this part. So Avogadro's law states that volume is directly proportional to amount of gas present at constant temperature and pressure. So V is directly proportional to N. So now we could see the relationship between the number of moles and the volume. If volume increases, the number of moles increase. Number of moles will, when the number of moles increase, the volume will increase. So of course that makes sense, because let's say you're adding, you're inflating a balloon. The more air you add, the more volume you're gonna see, the more expansion of the balloon, right? So now that we have this formula, how can we use this formula in order to calculate the liters of gas produced? So over here, we start off by getting the number of moles of gas present. So number of moles of CO2 is equal to mass over molar mass. So we know the mass is 125 grams. What is the molar mass of carbon dioxide? So we have carbon, that's 12, and we have oxygen, and that's 16 times 2 because we have 2 oxygens. So 12 plus 16 times 2. And then over here you would get 125 grams over 44 grams per mole. So now we do the calculations. We do the calculations over here. So we cancel off the grams with the grams, so we're left off with the moles. 2.84 moles. So now that we found the number of moles, let's see how many liters would that come up to. So we know that in 1 mole there's 22.4 liters of a gas. So in order to find how many 2.84 moles have, we simply multiply this relationship by the amount of moles that we have. Cancel off the units, and we get, let me do the calculation. So if we calculate 22.4 times 2.84, that should give you 63.6 liters of carbon dioxide.